Welcome back to my YouTube channel. In this video, we are going to look at part 2 of coordinate geometry, where we are going to be solving exam examples. Here in the question 1, we are told that the points P, which is -5, -2, and Q, -1, 6, R, 7, 7, and S, 3, -1, are the vertices of a parallelogram as shown in the diagram. So I have just indicated those points just to relate to what we are given in the instructions to what we are given on the drawing so that we don't get our points mixed up. I would also advise you to do the same if you get a question like this in the exam, that you label them so that you don't get your points or your coordinates mixed up. In A, they want us to find the length of PQ, and we should give it in the form k square root of 5, where k is an integer. So indirectly, they're just asking you to calculate the distance of PQ, and they just went further to kind of give you a hint on how your answer will look like, which is k, an integer, and square root of 5. According to what we learned in the previous video, and we should square that, and we should add, changing y, which is 6, from which is y2, minus -2. So we have to be very careful when we are writing this. So what we have there, and remember the formula says we should square root this. So now we try to simplify this. -1 plus -5 is actually just going to be -1 plus 5. -1 minus -5 is just the same as -1 plus 5, which gives you a 4. So we have 4 squared here. And then we have, just keeping the brackets just so that in case you get a negative number, you don't get it mixed up. And 6 minus -2 is the same as 6 plus 2, which gives you 8. So we have 8 squared. So that gives, so we have 4 squared, which is 16, plus 8 squared, which is 64, square root, which gives you square root of 80. And if you press that on your calculator, you write it in the side, it gives you 4 square root of 5. So that is how you're supposed to solve A. So very important, read to understand your question, and then you try. Remember, you must be responding to the question. They said you should give your answer in the form k square root of 5. So if you left your answer is square root of 80, then you have not found it in the form that you're given in the question. Continuing with finding the coordinates of the midpoint of PQ. When we talk about midpoint, we're talking about a point there. So we're saying M here. So we want that midpoint. So how do we find that midpoint? We know, and if we recall carefully, we know we are supposed to add the x together and then divide by 2. So we have -1 plus -5 divided by 2. That will give us the x coordinate of the midpoint, and the y coordinate will be -2 plus 6. Don't forget that this is negative divided by 2 as well. So what is that? This is -6 divided by 2, and this is 4 divided by 2, which gives you in the end the coordinate of M, which we are going to say it's -3 and +2. So that is the coordinate of the midpoint M. So now that we know the coordinates of M, we are going to solve C here. So C is saying we should show that MS is perpendicular to PQ. So when we got that M is -3, 2, right? And we remember that S is 3, -1, right? So we need to get the gradient of MS. So we need to get the gradient of MS, and we also do not forget that we also need to prove that MS is perpendicular to PQ. We want to prove that the product of their gradients gives us -1. So we go back and say P, which is -5, -2, and Q, which was Q, it's -1, 6. So we want to find the gradient of M of PQ, the gradient of PQ and the gradient of MS. So if we call that this is, if we are now going to say, okay, since we want to find, so we can say that this is x1, y1, and this is x2, y2. So this will be x1, y1, x2, y2. As easy as it might seem that I can just remember this, I don't have to label it like that. It might be you are writing an exam, you might be anxious, you might be nervous. we don't want you taking chances. So it's just advisable for you to just label them so that you don't get your coordinates mixed up. So to get the gradient of ms, I'm going to say change in y, which is -1. Remember the negative that is coming with the number and the negative that is coming from the change, like the minus. So change in y, which is y2 -1 minus y1, which is 2, divided by change in x, which is, remember, x2, so 3 minus -3. And what is that? That is -3 divided by 6, which gives me -1/2. So the gradient, which we can call m1 of ms, is -1/2. Then we come and continue with the gradient of pq. So to get the gradient of pq, we're going to say change in y, which is 6 minus -2 divided by change in x, which is -1 minus -5, right? So -6 minus -2 is the same as 6 plus 2, which is 8, divided by -1 minus -5 is the same as -1 plus 5, which is +4. So 8 divided by 4, which we are going to call m2, is actually 2. So now that we have our m1 and m2, therefore we will say -1 times 2 gives us -1, right? Because it's like that, then it's -2/2, then it's -1. See, therefore, which implies that m1 times m2 is indeed -1. We can then conclude that ms is perpendicular. Because of this, because we have proven that the product of the gradient is -1, then we can say that ms is indeed, we have proven that it's indeed perpendicular to PQ. We have proven it. When you see the word perpendicular, think about, remember, the product of the gradient is -1. When you see parallel, remember, they have the same gradient, perpendicular lines. The product of the gradient is -1. Okay. There's another question to spice up things. We have question D for that exercise. So question D, I'm going to just start it now. Question D is find the area of that parallelogram. So I've just taken part of the parallelogram and just sketched a parallelogram there to relate to what we're given in the other question, just so that we can see what is important. If we should not forget that area of a parallelogram is going to be base times height, right? So what we are going to do is we need the base, which is the length of PQ, which we have already found. Base is the length of PQ, which you already found to be 4 square root of 5. We have found that. What is the height? The height is ms. Because if this is the base, then the height would be that. Because we said that previously we have proven that this line is perpendicular to this line. So it means, and we know that the base should be perpendicular to the height. So it's fair to say ms is the height. So now we need to find the length of ms. So how do we find the length of ms? We know that we will say, doesn't matter which one you call your x2 and y2 and all that. So we can just say -3. So we can take the first one, -3 minus 3 squared plus 2 minus -1 squared. And then we have to say that ugly square root. It's an ugly square root. Okay, so that we have to square root. Yeah, not the perfect one, but it's better than nothing. So what is that? That is a -3 minus 3 is -6, and -6 squared plus 2 minus -1 is +3 squared. So we have to square root that. And what is that equal to? We have -6 squared is 36. And if we square 3, we have 9. So 36. So 36 plus 9 is 45. So we have square root of 45. And if we want, we can write it in third form, which is 3 square root of 5. So we have to multiply that with 3 square root of 5. And what is that? That is going to give us, if we multiply, so we got our length ms, which is the height. Now we have to multiply it with the base. And that gives us on your calculator that if you multiply 4 square root of 5 times 3 square root of 5, that will give you 60. So we have our 60 units squared.